Guys, welcome back to this part of YouTube. This is Mastat, your host. I hope you guys are enjoying the videos. And again, don't forget to hit that subscribe button and that bell so you can be alert when I post a new video. Today's topic, we're going to talk about algebra of function. Without any delay, let's get active. In today, we're going to talk about performing operations of functions, right? So, basically, addition, subtraction, multiplication, and division of functions. And as you can see on the screen right now, it says if f and g are functions. Now, remember, we used to talk about one, like f of x or g of x or things like that. But now we're talking about two functions. We have two now. If f and g are functions of x, are functions, and x is an element of the domain of each function, then basically you can write f plus g of x equals to f of x plus g of x, f minus g of x equals to f of x minus g of x, f times g of x equals f of x times g of x, and f over g of x equals to f of x over g of x. Basically, it's kind of like, remember we had this for the exponent. We had that, when we have a of x times a of x is equal to a to x, right? Or remember we had when we have this, let's say we have x times 3y plus 5z, that will be equal to 3xy plus 5xz. Well, it's basically the same thing. What that is doing is basically saying that's called distributive formula. So yes, even in functions, we also have the distributive formula. Now, the next thing we want to talk about, I want you guys to pay attention because it is not the same thing. Now we're going to talk about the definition of the composition of two functions. And as you can see on the screen, it says, so let f and g be two functions such that g of x is in the domain of f for all x in the domain of g. Then the composition of the two functions denoted by the f with that little circle and g is the function whose value at x is given by f of g of x. So what I was saying is this. Earlier we saw that f times g, right, of x. And on that case, guys, f and g are separate, and only x is an element of the domain of each of those functions, right? Here, f times g of x is the only function or the only element of both functions. This is equal to f of g times f of x times g of x. But here we talk about the composition. So the composite, or also called composite, and guys, don't get confused. The composite is basically a function inside of another function. So when you write f, and that's the circle g of x, so what they are basically saying is f here is the bigger function, right? So f is the bigger function, and that g is inside f. Alright? So in a sense, it's basically f of g of x. So what that means is the x now x is both an element of g and f, but f is first put inside of g, and then you calculate g of x. Once you calculate g of x, you take that, you put it inside of f to calculate f. Okay? And of course, we're gonna do some exercises so you guys can see the difference between the f times g of x and f of g of x. So guys, right now, I'm not gonna go to the exercise right now because I wanted to make sure that you guys can see the difference. So f times g of x does not equal f of g of x, right? Those are two different things. Okay, so be careful. You have to make sure you look at it properly before you jump into doing the exercises. So guys, this is my stats. I hope I explained that part pretty clearly. And next time we're gonna meet for part 2, we're gonna look at the exercises so you can see the difference between f times g of x and f circle g of x. I hope to see you guys again. Until then, my stats out.